Devon Energy. I want to thank ARC for having me to speak today about what we're doing at Devon. And I'll try to be brief so we can get to the beer. Okay, a little bit about Devon Energy. We're a, hold on a sec here. We're oil and gas company based in Oklahoma City. We are primarily based onshore in the United States and Canada. I say primarily, totally. We have a very balanced oil and gas portfolio, pretty evenly mixed. We are trying very hard to really inject technology in really every part of our business to really gain value from some of those the new innovative technology that's out there. So we've got some small groups that are really leaning very heavily in those areas. Our inventory of future projects is mostly based in the western Oklahoma area in the Stack play, as well as southeastern New Mexico in the Delaware Basin. Here in the last couple of years, we've really been focusing on trying to kind of develop that culture of innovation that kind of everybody seems to be after, so just like everybody else. And we've had a lot of success, teaching the business how to accept failure. It's not, kind of in the nature of a successful company to want to fail. But in order to be innovative, you really need to be able to do that quickly, iterate on those failures, and then get to the successful part as soon as you can. And so we've had a lot of success in that area. And here recently, we've really started to kind of adapt to that culture very well. Hopefully you'll see some of that today. Everybody always asks kind of how we're set up from an organizational standpoint. Where's IT, where's OT? We are separated between the business side and the IT, traditional IT side. My group is the Real-Time Systems group. We're responsible for getting all the data out of our SCADA systems, our OSI Soft PI system, and into the business to make decisions with. We're in the data and analytics group, which is in part of our E&P business, so it's actually on the business and production side of the house. We work very closely with our SCADA and automation teams, as well as the users and the engineering, management, and such in our corporate tower to deliver whatever products they need or whatever solution spaces they may need. We work very closely with our IT counterparts. We have a development group within IT as well that we lean on very heavily and try to make sure that the things that we deliver to our business users are collaborated and integrated well with our IT strategy. A little bit about our system. On the left, here's our SCADA systems, around 6.5 million tags at the moment. Those will update anywhere from 1 second to maybe 15 minutes, depending on the asset that we're looking at. We also, in the middle here, we forward all that data from SCADA into our OSI Soft PI system. And then on the right here is our business user. A business user in this context is going to be somebody in our Oklahoma City office in the corporate tower. Whereas the person on the left-hand side of the screen would be more of an operations user, maybe a technician in the field or a lease operator on site at the well. So one thing when we started this kind of process of how do we start really utilizing this data, making decisions from it either in real time or in history, is that SCADA data is very different from an operations standpoint than what your business user really wants to make a decision with. So SCADA data's got a lot of data anomalies where you may have a spike here from a sensor or maybe a null value. You may have data that goes stale for a period of time where you're not getting updates. There's many reasons for that. Could be electricity on site, whatever. The business person doesn't really care about why it didn't update. They just know it didn't update, so your phone rings and there's no data. So what we want to do is have this piece in the middle, and we use our PI system for this very heavily. To do some data quality, do some metrics around the data, try to remove those anomalies if we can. Also aggregate data, because that business user usually doesn't want the 1 second data or the 1 minute data. They're usually after something a little bit higher level. So we'll aggregate that data to maybe hourly, daily, weekly, monthly, whatever their reporting requirements may be. And then we want to turn that into something that they can trust. So that's what the data quality is for, and as well as something they can actually take action on. We'll talk more about that in a little bit. The other big thing SCADA has that the business software really can't deal with well is inconsistent data rates. So you may have one sensor on the same asset that updates every second. You may have another one there that updates once a day, once an hour. You get these different rates, and so lining all that data up into a nice table form that most business software can consume and use is really not very easy. Those time series data sets are much more tailored to like more of an operations type platform. So we want to normalize that model for time and get everything in a very periodic and more maybe not linear relationship, but one time stamp a whole bunch of data in a table and then have a bunch of those records. So that things like Power BI or Spotfire or Tableau or whatever software you may want to use to do get more insight out of your data can get access to it. So that also puts data in a place that's basically globally accessible to your entire enterprise in a form that you don't have to make special considerations for the software you're going to consume it in for. So it's already in a SQL-like table-looking fashion. It's ready to be used by lots of different people because most everybody's IT departments have very good SQL people. They have very poor time series people, usually. So next. So I've got a couple of screens here that just show some real-time operations screens, and just kind of highlight, from a real-time data standpoint, these users are fairly different. You might have an engineer or a user that just wants to see right now what's happening on site, and maybe they want to just watch that job and stay alert to what's going on. On this is a similar slide. It's actually got the same kind of data on it. It's just presented in a slightly different way. So this person is looking for particular phases within the job. They're looking to see what is happening right now and what's getting ready to happen. So these are really more of the kind of operational screens that maybe a technician or an engineer that's really watching this job closely is going to view. But on the business side, the business users, what they come and ask us for is, okay, well, that's great that you've got this real-time screen. That doesn't really help me design my next well. I can't really design the drilling program for the next well based on all this real-time data. What they want to do is take a bunch of wells that are all in a similar area and compare and contrast how that job proceeded. And so when we do that, we can take a bunch of key metrics from a bunch of different jobs, maybe 4 or 5 wells in an area. These wells would all be grouped based on maybe similar rock type or geological areas. We remove time as a dependency, and we'll plot everything against depth. And so we've got some metrics here plotted against depth for various wells. And what the engineer can do now, the design engineer for the drilling program, can come in here and say, okay, well, what kind of drilling bit were they using? How fast were they spinning it? What kind of tools were they using? How much weight were they actually putting on the bit? And they can start to see what worked really well in an area and what didn't work very well. And when we know that we're going to be drilling into a similar area, we can design, based on this past data, a drilling program using the proper tools, the right rates, all that stuff to get to the optimum design for that well. Okay, so I've got a couple of examples for you, some other more detailed examples on some of the stuff we've been doing. One of them is related to our drill out program. So I thought I'd briefly describe for those of you that aren't in oil and gas what the well lifecycle is and what we're talking about. Drilling is, well, making a hole in the ground. Completions is the process of really kind of preparing all the rock downhole to really extract the most value out of the rock, the most oil and gas. Drill out is kind of a final cleaning out of the well and removing any of the plugs and stuff we've set in during the completion phase. Flowbacks initially open up that well and recovering any fluids or materials that we used during that completion. And then production is the piece everyone's familiar with, which is getting the black stuff out of the ground. The part we're going to focus on today is this drill out section. It's like a 1 to 2 day period. A little bit more info. Uh-oh. You guys saw the results too fast. Okay, so there's a lot of red on there, right? It's bad. So during the completion, we come along in my wellbore diagram here, we'd come along and set these red and black plugs that you see in the diagram. So we'll work down here in the toe of the well. We'll do some completion work, and then we'll set one of these plugs. And that space there is called an interval. And we'll go along the well, and we'll do this over and over again as we work our way back up to the top of the well. So before we can get oil out of the ground, we have to remove all those things because we've really just very efficiently blocked the entire well off from getting anything out of it. And so we put a drill bit down in the hole, and we will come back down through here and we'll drill out all of those plugs. And so what can happen, just like if you were to take, and these plugs are typically like rubber or composite material. So if you were to take a hand drill and put a drill bit on it and try to drill through a thick piece of rubber, that's not very easy. Lots of bad things can happen. You can get stuck, you can get over torqued or whatever. Same thing can happen down hole. So you get your drill bit down there, you start getting these plugs broken up and try to flow the particles back up to the surface, and bad things can happen. So if you have bad practices during this thing, you move too fast, you move too slow, you're not kind of right in that sweet spot, you get stuck, and this can be very expensive to recover from. It can be $1 million per event or more. This can happen multiple times per well. There could be anywhere from 20 to 60 of these plugs in a single well bore, and so there's just lots of opportunity to get stuck. So what we found was that we could get a lot of these data sets from the vendors, and then we could actually hook up real time to these data feeds as well while this job was going on. We wrote some analytics. I don't have any details around the analytics on this, but just the results here in a second. And we're able to now monitor these jobs real time and have staff that's either dedicated to or know they are responsible to watch these, and they can use this information to see the precursors occurring, and we've got analytics running that will actually flag these events that will say, hey, something might be getting ready to happen, and they will go ahead and intercede, and they can prevent these things from occurring. So what have the results been? So since we implemented this program in the middle of 2016, we haven't had any stuck events. On average, in 2015, we had a stuck event 1 out of every 16 wells. So we're on about a 40% reduction in cost right now for this, as well as a 50% reduction in time. And you can see really what drove that high cost before. Those top 10 events of 2015 averaged about 1.7 million each, where the typical job should be somewhere around 300,000. So we're seeing great improvement here, and exactly what we'd like to see from a results standpoint. This next one that I've got is a haul-off marketing example for tank inventory. So a tank battery is a facility out on a well site that just has a bunch of storage tanks set next to each other, and they're to store oil and water. Whenever those get full, we need to take that oil and either put it in a pipeline, or if you don't have pipeline available, you can take it into a truck, a hauling truck, and take it to a point of sale or to a custody transfer point. And so these guys pull up on site, they hook up some hoses, they get their liquid to flow, and then they write down on a piece of paper how much they took. Sometimes there's a mailbox on site, they'll put that piece of paper in. Often it is a glass jar that they shove that piece of paper in, and they'll set that somewhere on site, almost like it's hidden, and somebody knows where that thing is, and they go pick it up, and that's how we know what they picked up. Sounds crazy. Really happens. So what we thought was, hey, we've got SCADA on all of these tank levels, why not use it? And we could maybe even not only detect when there's somebody on site taking oil, but maybe we can even just know how much they took and eventually match all those things up and have like an actual audit trail for what these guys did on site. That would be amazing. So that was the goal. So we want to do things like know when a truck's on site, how much did they take, did they pick up water or oil, were there more than one truck on site, did they take a full load or did they take just a partial load? We don't want them taking partial loads. If they come and fill up 25% of the truck, we're still paying for that whole truck. We want them to take a full load every single time. And can we predict when that next load needs to occur? Can we start seeing 3-4 days in advance, oh, we know we're going to need 3 trucks at that site, and we can start scheduling a little more efficiently? And can we gain enough data so that we could actually grade some of our service providers? Are they doing what they've told us they were doing? The way it was before, and even today sometimes still, you just don't really know if what they say is occurring is really occurring, because you've got a lot of wells, you don't have people on those wells 24/7. You need to be able to track this data. So the first thing we did was, we've got real-time data, we can give some situational awareness to some of the operators. On the left is oil, the right is water. If it's green, it's good. There's no reason to call in a haul right now if you don't need to. This is really more of a reactionary screen, so this is if things get out of hand, we need to know where to go and how fast we need to get there. If something turns red on this screen, then we are nearing capacity from a storage standpoint, and we need to dispatch a truck. immediately, or we'll have to shut in production and actually lose production. Okay, so what we really want to do, though, is detect these Hall events occurring in real time, so we know, hey, someone's on site, they're taking oil. So that's pretty easy to do with our eye. We can see those Halls occurring. The blue line here is total volume in the battery. And so when you see that big take, pretty easy to say, well, there probably was a truck on site and he took some oil. If he only took 20 barrels, well, maybe we spilled. Maybe we can detect spills then. But training a computer to do this, not terribly difficult, but still more hard than just visually looking at it. And so typically the way this would work in the past is we'd have a developer pair up with our engineering team. The engineer that's responsible for this data, he knows his data really well. He can tell you all the edge cases of this data. He can tell you, when certain conditions occur, why he wouldn't, maybe add here or subtract there. The developer is just going to take what that guy tells him and try to implement it for him. So typically you're working a 2-week sprint, and you'll go through this cycle of, hey, developer goes off of work, he comes back, hey, how's this look? Oh, you need to fix this or that. So you do that over and over again. Before you know it, you're 10 or 12 weeks into this project, and you're still not delivering anything yet, even from a prototype standpoint. So what we want to do is give our engineer a tool to help him to go through all these cases as fast as he possibly can. And the way we do that is with a program called Seek. They're here today as well. You guys can talk to them as well. If you'll play that for me, that'd be... So I'm just going to kind of run through a quick 2-minute demo of kind of detecting these events in Seek and show you what we're talking about. So we're kind of hooking up straight to our OSIsoft Pi data right here. So we're pulling Pi data in directly. We don't have to copy it or anything like that or stage it. The first thing the engineer is doing here is cleaning up the data. So we're applying a smoothing function to the data to remove the jaggedy edges. That's a technical term. And then the first thing he'll try to decide what does he actually want to do to detect those events. So what he decides is he's going to take the derivative of that time series data set, and then you can quickly see, hey, wherever that slope goes negative, we must be taking a haul. So he's very quickly in this just kind of UI. He can point and click around. He doesn't have to write a lot of math. He doesn't need to know a lot about programming. He can come up with his capsules or his events. And so you can see those at the top there, kind of in, it's hard to tell what color, purple. And he's got a couple cases where he didn't quite get what he wanted. So he's going in here and refining this math just a little bit to remove some of the edge cases that he knew he was going to get. And so now he has, visually looking at this, it looks like he's detecting everything that we want to detect. That's great. So the next step would be, one of the questions we asked was, so now we've got these events, we know when they occur. Can we actually figure out how much oil they took? Because that was sort of the whole point of this, was to match up what they said they took to what they actually took. So now he's going through and filling this UI out and figuring out, based on these events that have occurred, can I take the time where it started and the time where that event ended and come up with what was the range of that value? And so he's pretty quickly created a time series data set here. So what we like about this is that we can get very high iteration from our engineer, the guy that knows his data. He can go through here and really get what he wants out of this data before he hands it off to development to say, this is what I want, or they can just continue to monitor it in this UI here. So we see here that what he came up with was somewhere between 115 and 125. Well, I can see that. I don't know if you guys can. And that's good because a water hauling truck holds about 120 barrels of water. So it looks like his math is working well. So we've got this process where we can get data in real time. We can take that data, run it through Seek to get some output for an asset. We want to apply that to every battery that we have, and so we've got thousands of batteries. So we've got an API in Seek that we can use, and so we tie into their API layer, and we've got a custom app that does a little bit more processing on the data as well after Seek's done with it, and then we write that data back into our Pi system, so it's now available for things like that operations dashboard I showed you earlier, as well as our real-time visualization system. So now we want to report on it. I told you earlier we like to use Power BI. So this is a Power BI shot of that same data that we created in Seek, detecting those events and how much was taken, as well as the ability for them to kind of slice and dice this data however they want in their tool of choice for reporting here. Okay, so now we're to the thing where we're ready to figure out how to make the scheduling easier for the guys that are calling all these halls in. So before, the way this process worked, they used Excel to manage the field for this. It's the greatest tool ever. And so what they do is they, like most places, they'll send out an Excel file in the morning. It goes to 10 people. Those 10 people fill in their data. It comes back. Somebody collates all that data into one big file, and now they're ready to start calling in their hauling. Well, we changed that to where we've got this green button now, Get Loads, and they push that button, it goes into the Pi system, it pulls all the data in, all the stuff that we've now generated. It can pull that in here, it can forecast up to 3 days out and fill in their Excel file for them. So you may be thinking, okay, you guys did all this analytics and you used all these cool tools and you've got these dashboards, why are you still using Excel? Well, we didn't want to change everything the user was doing. They like their Excel file, they know how to operate on their Excel file, they know how to share it, they're comfortable with it. So for this stage, all we did was replace the way we get the data to them, make it so they can get that data faster, on demand. They can request updates to this data any time of the day they want to, just push the button. There are lots of opportunities here to improve the scheduling process. Something I'd really like to investigate would be potentially the use of something like smart contracts and blockchain or something like that. I had to throw in some cool buzzwords. So here's our system now. We've got different users. We've got operations users that want to react to data. A truck scheduling is better now. We got real-time screens, and then we've got this tool now that we can allow our engineers to go in there and improve their data with an analytics platform. All right, so I'm probably running short on time, so I won't go through everything here. But one thing I did want to mention is, initially we talked about how do we match up those haul tickets. Okay. How do we match up the haul tickets to the kind of the automated process that we just talked about, and kind of marry those together so that we can have kind of a full audit, like traceability of everything that happened on site and what the vendors are charging us for. And so that's the next step. We have a project running right now to accomplish that, and things are going fairly well there. Like anything, the devil is in the details on that as well. See, I think I've got one more. Okay, so if you're not using your data yet, how do you make your data valuable? I would just say pick some data and use it. We talked about there's data everywhere in our organizations. I wouldn't pick a big, maybe high-value project. You don't have to have a huge project to make an impact. You could pick one person's job and say, how can I save you 5 minutes? And that will snowball into hundreds of people asking for your time to go help their processes as well. Before you know it, you'll have saved lots of money. Data quality is huge. We found that our users really don't like all the weird stuff that happens in SCADA data. So on the business side, we're trying very hard now to present a more unified, cleaner view of data for those users. I said start small, so just start small in increment and really focus on making your data actionable. It's easy, and I do the same thing to make cool data that you can make a really cool looking chart with. That just looks neat, but maybe it's really not that valuable. It just is a cool way to show data. Try to make it so that data that you're showing on screen is something that a user can use to make a decision with. And with that, I'm all done. You guys are we doing questions now or later? Now?